In this recording, we're going to learn how to solve quadratic trig equations. So just like the linear trig equations we learned about last time, but now there's a square somewhere in the equation. So let's approach it the similar way. If we have a quadratic trig equation, like the one we're about to look at, we're going to look at a very similar equation just with m's in it. Okay, so I'm going to solve this equation using the quadratic formula. Okay, so let's write out our quadratic formula. X equals negative b plus or minus square root b squared minus 4ac all over 2a. All right, so we always like to write out the a, b, and c. It's in standard form. We have an equals 0, so we can say what a, b, and c are. Why don't you proceed to work this out, get as far as you can, and then play the recording when you've got your answer. All right, so hopefully you pause and work this one out. We're going to say a is 2. B is 1, C is negative 1. Notice that there's no m's here, it's just the coefficients. The first thing we like to do is work out the discriminant. So b squared minus 4ac, work this out. So 1 squared minus 4 times 2 times negative 1. I believe when we work this out, it works out to be a 9. Great. So go to our full quadratic formula. X equals, really it's m equals, but we're okay with that. X equals negative b, so negative 1, plus or minus square root of 9. Remember, that's the b squared minus 4ac. All over 2a, so all over 4. Now we just got to make this simpler, so that's equal to negative 1 plus or minus 3 all over 4. Let's split that off into two equations, or two expressions, I should say. The one is negative 1 plus 3 all over 4 works out to be 2 over 4 or half, right? And then negative 1 minus 3 all over 4. That's negative 4 over 4, negative 1. So those are the two answers to this quadratic equation, half and negative 1. Now the equation that I'm about to bring on board here is a very similar equation. I'll paste it in the other screen so you can see the similarities. Okay. I want to solve this equation between 0 and 360 degrees. Notice how everything's the same. Essentially, we can change. If we get an equation like this, we can change the sine theta into an m. Work out with our quadratic formula what it is. Now, if you say, I can just factor this, great, have at it. I'm going to suggest using the quadratic formula. I think it's probably a good sort of one-size-fits-all method for solving quadratics. Let's undertake this trig quadratic equation, quadratic trig equation. All right, so same method as before. We're going to rewrite with the m's. So if you get this equation, I'd like you to write this all down. Let's rewrite as 2m squared plus m minus 1 equals 0. See above, solution using the quadratic formula. All right, so we got that figured out, right? So we know that given the quadratic formula, m equals half, and another possibility, or m could equal negative 1. So let's turn these back into signs. So sine of theta equals half. Is that a possibility for sine theta? Sure. It's between negative 1 and 1. And the other option is sine of theta could equal negative 1. Okay. So for sine of theta equals half, we want to make it positive. It already is. We'll do our inverse sine to get the reference angle. So we'll do the inverse sine of half, and that works out to be 30 degrees. So we know that's the reference angle. Because it's positive, we're going to think about the two quadrants where sine is positive. Circle those two, please, and then play the recording. So hopefully you say, well, it's in the all quadrant and the S quadrant. So 1 and 2. So we've got a 30-degree reference angle in quadrants 1 and 2. So I'll start out by making quadrant 1. 30 degrees is here. That's just 30 degrees. You might say, do I even need that picture? No, you really don't. Quadrant 2, however, I like to make the picture. For us visual sorts of people, it really helps. Okay, so you've got a 30-degree reference angle in quadrant 2. What does that angle look like? Well, it's 180 minus the 30, it's 150 degrees. So I've got 30 degrees followed by 150 degrees. All right, so each linear trig equation, the sine of theta equals half, tends to have two solutions. It often does. So the quadratic trig equation could have double that many. If you remember from our linear trig, we said a linear trig equation could have 0 or 1 or 2 or even 3. So we could have up to 3 here. We could have, I suppose, up to 3 here. Go from there. Now, for sine equal to -1, you could put it into your inverse, but I'm going to suggest just thinking about the graph because there's not really a way to make a reference triangle. So just think about a sine function. Where's the graph equal to -1? Right there. What's this value? 270 degrees. Okay? That's the other place where we have a solution. So here we're saying the sine is 270. Okay? So then I just need to put all those answers together. Theta could be any of the following: 30 degrees, 150 degrees, or 270 degrees. Okay? Let's look at one other. Okay, so this is a beta, a Greek letter beta. Okay, it's the second letter in the Greek alphabet after alpha. All right, and we're going to solve for beta. The reason I'm throwing this beta in here is just I don't want you to be thrown off. If you see other variables like x's, y's, betas, thetas, alphas, they represent angles. Okay, and I want it between 0 and 360 degrees. So we're going to answer it within degrees. This type of equation is quadratic, so I'm going to turn it into m's. M squared equals m. Okay, just like before, I'm just going to be consistent with that technique. I'm going to solve it using the quadratic formula. I could factor, but I'm going to use the quadratic formula. Get all the terms on one side. Okay, go to my a, b's, and c's. A is 1, b is -1, c is 0. Why don't you work this out with the quadratic formula? Play the recording when you've got something, please. Okay, so the b squared minus 4ac, -1 gotta be in parentheses. Big time source of error there. Okay, so that whole thing is 0, and this just works out to be a 1. I go to my quadratic formula. X equals -b, so a positive 1, negative, plus or minus the square root of 1, that's the b squared minus 4ac, all over 2a, so 2. Okay, so let's split that out into our possibility. So it's 1 plus 1 over 2. Well, that looks like 2 over 2, which is a 1. We have 1 minus 1 over 2. That's 1 minus 1. That's 0. So my two options are 1 and 0. So basically I'm interested in knowing if I turn those m's back into sine betas, sine of beta could equal 1, and the sine of, that's sloppy, let's do that again. Sine of beta could also equal 0. I think probably the best way to think about this is just your graph, your basic sine graph. And consider the points along that graph where the y values are either 0 or 1. Let's do the 1s first. That's right there. I can only see one place, and that would be at 90 degrees, right? And then you might be saying, well, isn't it pi over 2? Yep, it's pi over 2. But we want the answer to be in degrees. And now I see 3 places where between 0 and 360 it equals 0. So 1, 2, 3. We need to list all of them. So 0 degrees, 180 degrees, and 360 degrees. So all of those are values of beta. I'll write them in the numerical order. 0, 90, 180. It doesn't really matter the order, but I'll just put them in numerical order. Okay, those are your your four solutions to that quadratic trig equation. Thanks for watching.